Hey, welcome. In this video, we're going to talk about factoring special cases. But first, I want to talk about this for a second. I want you to try this problem. Let's say we have, just going to go over to the side here and just find some place to write this down. I have x plus 2 times x minus 2. Right, now look at this. There's obviously something special going on here. They both have the same leading term. They both have the same end term, and the only difference between the two of them is this one has a plus and this one has a minus. I'd like you to go ahead and FOIL that and see what happens when you do that. So go ahead and multiply those together. Pause the video, multiply them together, and then rejoin me when you're ready. Okay, so when we multiply first, we get x squared. Then outer, we get negative 2x. Then inner, we get positive 2x. And then last, we get a negative 4. Now notice the negative 2x plus 2x, well, that's just going to simplify to 0. So we have x squared minus 4. What we call this is a difference of squares, right? The difference of squares is a binomial. Has to be a binomial, right? So two terms. And the first term has to be a perfect square, and the last term has to be a perfect square. So like x squared is a perfect square because the square root of x squared is just x. And then 4 is a perfect square because the square root of 4 is 2. All right, so now let's start the notes here. So the difference of squares. So that's when you have some number a squared minus some number b squared. And it could be factored quickly. Okay, you're not going to find a GCF or anything like that, but it just becomes the quantity of a plus b times the quantity of a minus b. Okay, the first step to factoring a difference of squares is recognizing that it's difference of squares. Because what will happen a lot of times is I'll see students get to a difference of squares and think that it's not factorable. Okay, so you have to notice that it's a binomial, right? So two terms. Next, you have to notice that both of the terms are perfect squares. So what I showed you off to the left there. And then the last thing you have to notice is it must have a minus sign between the terms. And the rule is often written as you see right here. Okay, so how do you factor the difference of squares? First, you need to find the square root of each term. So if it's perfect square, then you can find the square root of it. It's going to either be an integer or a variable. Next, you're going to put it into two sets of parentheses, and I'll show you all this below. And then you're going to put a plus sign in one and a minus sign in the other. All right, so are the following examples of difference of squares? If so, factor. So like I said, the first thing you need to do is actually recognize that it is a difference of squares so you know the proper way to factor it. And it's right in the name. We're looking for two perfect squares as the terms, right? So x squared is a perfect square and 4 is a perfect square. And difference, we're looking that they are being subtracted. And then it, of course, has to be a binomial. Okay, so to factor this, I'm just going to follow the steps above. It says find the square root of each term, put into two sets of parentheses. So I'm going to set up my two sets of parentheses. I'm going to find the square root of the first term. So the square root of x squared is x. I'm going to put it in the front for both of them. And then I take the square root of 4, which is 2. And I'll put it in for last for both of them. And then lastly, I need a plus sign in one and a minus sign in the other. And it doesn't matter which one gets plus and which one gets minus, so long as you put in one of each. So you can see how that relates back to this problem I gave you at the beginning, right? We took those two binomials and multiplied them together, and we got x squared minus 4. Now we're pulling them apart to factor them. All right, so now I need to see, are my two terms perfect squares? So 9 is a perfect square and x squared is a perfect square. So yes, that is a perfect square. 16 is a perfect square because the square root of 16 is 4. And I do have a minus sign in the middle. So I can go ahead and set up my two sets of parentheses here. Go a little bit smaller this time. I'm going to square root the first term. And the square root of 9 is 3. And the square root of x squared is x. I'm going to put it in both sets of parentheses. And then I'm going to take the square root of the last term, which is 4. And then lastly, a plus sign and a minus sign here. Okay, next one here. So looking up front here, 16 is a perfect square. X is a perfect square, but 5 is not a perfect square. So this is not a difference of squares. Now I could look further and see if it's factorable, right? This said, the directions say if it's a difference of squares, factor, but let's just see if it's factorable anyway, even though it's not a difference of squares. So in this case, is there a greatest common factor I can pull out? Is there anything that's common between 16x squared and 5? There's not. So it's not a difference of squares, and furthermore, it is not factorable. Okay, you probably want to pause and get those two notes in there. Let's look at this next one. So our first term, 8, is not a perfect square, and x squared is, and 2 is not a perfect square, but this one's a little bit tricky because you always want to factor out the greatest common factor first. And I actually should be bringing that up every single time we factor something. Always look to see if there's a greatest common factor first. My brain just automatically sees it, but that's something you should always be looking for, because if you don't do that, then you haven't fully factored whatever it is you're trying to factor. So is there a GCF between 8x squared and 2? There is. We can pull out a 2. Right? So now we have 2, and then I divide 8x squared by 2, and I get 4x squared. And I divide 2 by 2, and I get 1. Okay, so now let's reevaluate to see if we have a difference of squares now. So 4x squared is a perfect square. And 1 you might not recognize it right away, but it is a perfect square because the square root of 1 is just 1. So let's go ahead and factor this some more. We're going to set up two sets of parentheses. I'm going to take the square root of the first term, which is 2x, the square root of the last term, which is 1, and then one of these gets a plus and one of them gets a minus. Okay, so I've kind of saved the hardest one for last here, but I'm going to let you go ahead and give it a try. So pause the video, see if you can come up with it, and then rejoin me when you're ready. Okay, so is this a difference of squares? Well, 9x squared is definitely a perfect square. What about y to the power of 4? Well, if you think about this, y to the power of 4, y to the power of 4 is the same as y to the power of 2 squared, right? Because if I'm raising a power to another power, we'd multiply those together. So if you look at it that way, then it's the y squared that's being squared. So it is a perfect square. It is, in fact, a perfect square. So I'm going to go ahead and set up my parentheses. I'm going to take the square root of the first term, and I get 3x. And I'm going to take the square root of the last term. Well, if you think of it like y squared squared, and you take the square root, that gets rid of this here. So the square root of y to the 4th is y squared. And we have a plus, and we have a minus. There we go. Okay, now we're going to look at a perfect square trinomial. And a perfect square trinomial comes from a binomial being squared. Okay, so for instance, if I have x minus 4 and I square it. Okay, one common mistake, and this happens a lot, and so I'm going to just bring it up again so that way hopefully it won't happen to you. This is not equal to x squared minus 16 or x squared plus 16. Neither of these is correct. Okay, when you take something and square it, that means you're taking it and multiplying it by itself. So x minus 4 times x minus 4. All right, so let's do this the way it's supposed to be done, and you'll see that you do not end up with one of these. Right? If we longhand this out and do what it's actually saying, you'll see that we do end up with a middle term. So I'm going to FOIL this, and I get x squared, then outer negative 4x, then inner negative 4x, and then last is plus 16. These guys combine, and we get x squared minus 8x plus 16. So just to review here, if you multiply together, what's going on here, so two binomials that look the same but one has plus and one has a minus, you get rid of that middle term. It just ends up canceling out. As opposed to this one, when you square it, you do end up with a middle term here. Okay, so let's go over here now and talk about the perfect square trinomial. Okay, here's the notation for the rule here. Right, so we have a binomial being squared, and there is a pattern here, right? We have the squared first term, we have the squared last term, and then the center term is 2 times the first term times the last term. Okay, so just like when you want to factor a difference of squares, the first step is to recognize that it is a perfect square trinomial so that you know that it can be factored a specific way. This would also be a good time to mention that you can factor perfect square trinomials the other ways that I've showed you to factor trinomials. That's possible, but there's a good reason why I'm showing you that. There's two reasons. The first reason being you're going to get some big numbers, as you'll see in the practice. You're going to get some big numbers on the ends here that when you do the I-bar is going to get kind of hard to find out what the sum and difference is. You can do it, but it's just going to be a long process. Also, there will be a time in the near future when you'll be doing something called completing the square, and that's when you need to create perfect square binomials. So being familiar with them and recognizing them is just going to set you up to understand that better when you get to it. All right, how can we recognize a perfect square binomial? So you're going to see that the first and the last term are perfect squares. So in our example over here, x squared is a perfect square and 9 is a perfect square. Okay, the middle term, so let's find the middle term in this perfect square binomial, is 2 times the square root of the first term times the square root of the last term. Okay, so we know that this example that I have over here to the right, we would want to check the middle term to be 2 times the square root of the first term and the last term. So the square root of the first term is x. The square root of the last term is 9, and then we're going to multiply that by 2. And if that gives us the middle term, right, 2 times x times 3 does give us 6x, then we're almost there. We almost know that we have a perfect square trinomial. Okay, next thing that you need to notice is only the middle term can be positive or negative. And that's because if we square, if we look over here, if we're squaring something, that b squared is going to be positive. So this has to be positive. This can be positive or negative. And then when we go to factor it, you can use the middle sign in the factored binomial. Okay, that might have been a little confusing, but let's see it in action here. So let's look at our first one, and we need to confirm that the first and the last term are perfect squares. So take a look, x squared and 16 are perfect squares, and then the middle term has to be the 2 times, so 2 times the square root of the first term, which is just x, and the square root of the last term, which is 4. When I multiply those together, I get 8x, which is what I have right there in the middle, right? That's our middle term. So this is a perfect square binomial. So now it's just a matter of factoring it. And I did not write out steps here, so maybe we'll write some off to the side. Okay, I'm actually going to add these to your notes before I make them available to you. So let's draw parentheses squared here. So parentheses squared. And then we're going to find the square root of the first term. So the square root of the first term is x. The square root of the last term is 4, and then I'm going to, step number 3 is use the sign on the second term right there, so it's a positive. Okay, once you've determined, all the work in this is just determining that it is in fact a perfect square trinomial. After that, you just go ahead and plop the stuff into the parentheses that are squared. All right, so next one here looks exactly the same as the first one, right? So we've already checked that the middle term is the first term squared times the last term squared times 2 is in fact 8x. So we've already confirmed that. Everything looks good. Now we just need to look at the signs because I do have a negative in there. And there are negatives allowed, but only in specific places, right? So it says only the middle term can be positive or negative. So this is our middle term. It is negative. As long as this one's still positive, we're good. We can actually factor this. So I'm going to set up my parentheses. and I take the square root of the first term, I take the square root of the last term, and I use the sign on the second term there. Second or middle term, whatever you want to call it. Okay, last one over here. Again, it looks the same. The difference is that that is a negative. That means that this is not a perfect square trinomial. Notice back here, I used a negative, right? And when I squared it, I always end up with a positive over here because our negative times a negative is a positive. And that's always going to happen with a perfect square trinomial. That last term always has to be positive. So now, just because it's not a perfect square trinomial, maybe it could be factored anyway. If I wanted to go through that process, I'd want to look and see negative 16 and 8. What are the factors of negative 16? Well, we have 1 and 16. We have 2 and 8. We have 4 and 4. I think that's it. And none of those, right? One of them would have to be negative in order to multiply to negative 16. It looks like none of them, if I made any of them negative, they would not add to 8, right? If I made negative 4, we'd end up adding to 0. Here we'd have a 6. And here, yeah. So this one happens to also not be factorable. Okay, I'm going to give you one here because I want to make sure you got this before you move on. So I want you to see if this is a perfect square trinomial, and if it is, go ahead and factor it. So go ahead and pause the video and do that. Okay, so for it to be a perfect square trinomial, the first term needs to be a perfect square, which it is. The last term needs to be a perfect square, which it is. Okay, and now if you were to try to make your I-bar, right, you're doing 16 times 49, and it has to add to negative 56. That is a 6, not a B. Right? That's a lot of factors. That's a lot of stuff to look through. So this is one of the reasons why knowing how to factor perfect square trinomial makes things a little bit easier. So we're not done identifying that it's a perfect square trinomial. We still need to check, does the middle term equal 2 times the square root of the first term? So 4x times the square root of the last term. Well, 4 times 7 is 28 times 2 is 56x. It does. It's true that there's a negative there, right? But that doesn't matter over here when we're checking. That only matters when we're checking this step here, that only the middle term can be positive or negative, right? So looking back at our trinomial, only the middle term is negative. The last term is positive. So I have confirmed that this is a perfect square trinomial. So it takes a little more work on the front end than factoring it the regular way. But once you identify that, you can just go, okay, I'm going to take the square root of the first one, or sorry, the last one, take the square root of the first one, and then use the sign of the middle. All right, kind of a longer video there, but hopefully you got it all. Thanks for watching.